Next, let us find the inverse kinematics of articulated configuration. As you can see here, we are having again a given matrix of 0 t3 having some numerical values. Then we are having the goal, that is to find theta 1, theta 2, theta 3, because in articulated configuration we all know that it's basically 3 revolute joints. Already link lengths L1, L2, L3 are also given. So what is remaining is only to find out theta 1, theta 2, theta 3. We have already done this previously in articulated configuration. We have already done it previously, and based on that we had got certain answers. So we will try to do it here also. So first thing is we have to find out the link parameter table. So this is the link parameter table and the associated AI matrix in which we have to give different values so that we are able to find out A1, A2, A3. A1, A2, A3 I have already found here, which is A1 is given by this, the first matrix, A2, A3. The multiplication of all these three will give me 0t3. So we get 0t3 as this particular equation, which is equation number 2. And now we have to equate equation number 1 and 2, and when we equate it, we basically get this particular equation. So from this equation we have to find out theta 1, theta 2, theta 3. So it's not very difficult. If you would see here, from this one we will get, I will draw it for ease. From these two I will get what is theta 1. Once theta 1 is obtained, next we have to go for finding theta 2. So for getting theta 2 we can use the equation. Let me go back. For the S2, what we can do is we can use this particular equation. Here if you would see, L1, L2, L3 is the link length, so that is already known. Now here S2 is there, and other than that this big term S2 C3 plus C2 S3 is there, but this whole term is actually here, negative of that. So that is actually R31, which is this one, and this can be equated to dz. So directly if you would substitute, we will get L1 is known, L2 is known, L3 is known, and this portion is already known from here, so S2 you can find out. So theta 2 is also found in that way. So then let us look at how will we find theta 3. For that we can use this equation, because this is sine, or even this equation we can use many equations here. So if I am going to use this equation, or let's say even if it is this equation, this is going to be cos minus of cos theta 2 plus theta 3, minus of cos theta 2 plus theta 3, because that will be cos theta 2 cos theta 3 minus of, which will actually come out to be this one. So using that, theta 2 we have already found out, we will be able to find out theta 3. So like that we can use this equation to find out. Let us do this one by one. So I will say from 3 I will write from this minus S1 by C1 is going to be equal to R13 by R sorry, r 2 3, from which this will come out to be minus tan, so I will get tan of theta 1 is equal to minus of r13 by r23. Therefore I will get theta 1 is equal to tan inverse of minus r13 by r23. So with that I will be able to get theta 1. So there I have put in a box. Next, as I told, we have to find out theta 2. So as I said, if I look at this equation, that is equal to dz, of which this minus s2 c3 c2 s3 is already present here, which is r31. So I will write something like this, that minus L3 S2 C3 plus C2 S3 minus L2 S2 plus L1 can be written as, this negative, this portion is actually present here, so I can write that as minus, not minus, minus will not be there because minus of that is written here. So I will write this as L3 R31 minus L2 sine 2 plus L1 is equal to, now what is that? That is completely dz. Okay, therefore I can directly write here that therefore sine 2 will be equal to dz plus will become minus L1 minus L3 R2 R31, that divided by minus of L2. Therefore I will get theta 2 as equal to sine inverse of whatever is there within this, that is dz. So I will put that in bracket, dz minus L1 minus L3 R31 divided by minus L2. That will give me the answer. Let me put that in a box. So theta 2 is also done. The last is theta 3, which I said we can find out from this equation. So let me write that. So S2 and S2 S3 minus C2 C3, which can be written as minus of cos theta 1 plus theta 2, that is equal to, according to this matrix, that is equal to R 32. Or I can write theta 1 plus theta 2 is equal to, so minus has to go the other side, so it will become cos of minus R32, which we actually know that there is no point in putting a minus there because it is one and the same thing. Cos of minus theta is same as theta, so I can write it as cos inverse. So cos inverse of minus R32. So that I will not change. So that is the same answer because it's cos inverse. So now once we get that, so now, sorry, this was theta 2 and 3, sorry, I made a mistake here. So this is theta 2 plus theta 3. The same thing I have to write here. It is theta 2 plus theta 3. With that, I will get straight away. Therefore, I can write, therefore, theta 3 will be equal to cos inverse of minus r32 minus theta 2. Now, where is theta 2? Theta 2 we have already found out. See, now the same thing can also be solved by, many other methods are there. If you would, look into the equation, there are many other ways in which the same thing can be actually solved. But then, based on how people like, they can choose. I have just shown one method. So let me put that also in the box so that we are able to get all the answers correctly. So that is theta 3. So with that, we have found out for the case of an articulated robot how we will find the inverse kinematics. That means if given a matrix like 0 t3, how will we find out theta 1, theta 2, theta 3? Thank you.